Welcome to Unit 202. This is Digital Games Production. The aim of this unit is to promote your practical understanding of the key elements involved in digital games production and the wide range of potential games platforms and formats available to the consumer. The purpose of the unit is to facilitate practical opportunity to develop knowledge and understanding of games production techniques in context through the development of a game demo. So what you'll be doing here is you'll be following along with the Create with Code course that some of you may be familiar with. You'll be making at least 3 of those prototype games using Unity, which is a games engine. So, as mentioned, you've probably all worked out by now that Unity is a game engine. So is Unreal. What is a game engine? Well, obviously, it's the piece of software that you can use in order to make your game. So it has things like a physics engine, a way to use C# code in order to make the behaviors for your game. It can import 3D models, you can animate inside it, and everything which is involved in making a game. So we're going to just take a quick look at a comparison between 3 game engines in this short video.
So you want to become a game developer, but you don't know which game engine you should choose to create your games because there are tons of out there that you can choose from. Well, in this video, I'm going to give you 3 game engines that are going to be the best game engines in 2020. And of course, this year. Is this engine better? Is that engine better? Which engine has better graphics? Fahir here from simpleprogrammer.com. So let's get started. At the first place, and again, in no particular order, I'm going to mention Unity Game Engine. You probably heard of that. If you try to type game development, you probably saw some Unity tutorials, and there's a lot of speculation that is the most popular game engine. Well, it's between Unity and Unreal Engine, but again, it's not about that. So why is Unity Game Engine good? Well, first of all, because of the community and the support that it has. It's probably the game engine that has most tutorials and online courses out there where you can learn how to create games using that engine. It also uses C#, a programming language that you're going to utilize inside of Unity to create scripts that you attach on game objects and make them move and interact with your game and so on and so forth. And C# is a very powerful language. If you learn how to code in C# for Unity, even later on, if you don't want to continue creating games in Unity, you want to create something else, desktop apps or mobile apps or whatever, you can transfer that same knowledge into that field because it's transferable. It's object-oriented programming, so it's the same principles. C# is also a very good language when it comes to speed and performance in games. On the other hand, Unity also is a cross-platform engine. What does that mean? That means you build your game once and you can publish it on mobile, on desktop, on web, whatever you want, even on consoles and all other platforms, AR, VR, whatever, you can publish your game on those platforms by using Unity, just building your game once. Of course, you will have to tweak some settings like the movement and whatnot to correspond to the correct platform. So you will give right commands and right code for your player to move, for example, in mobile, and then to move in desktop and then console and so on and so forth. Unity also has a good graphic system and it's getting better and better every single time because when it comes to Unity and Unreal, people, when they compare them, they usually say Unreal has better graphics, but again, this is not in comparison, but I'm just saying that Unity has much better graphics than it had like 3 years, 5 years ago, so you can create really, really cool games. Unity is very flexible. It has a very good tool set for you to create 2D as well as 3D games, and many popular mobile games out there are created using Unity. Now, the second game engine, and again, not in any particular order, is Unreal Engine. And Unreal Engine is older than the internet itself. Probably the very first games you played on your computer or your Compaq or your Commodore 64 are created in Unreal Engine. In comparison to Unity, uses C++, not C#, and C++ is a faster language when it comes to performance in video games, but it's also a harder language to learn because it still is an object-oriented programming language like C# is, but there are a few differences between them. Now with Unreal Engine, you get incredible graphics. It's known by that. You can create like hyper realistic scenes that look like from the future, from the movies, from the videos that you watch that are like super high in FX. You can do that in Unreal Engine. Unreal Engine is more flexible towards 3D than it is to 2D. They only introduced like recently. Unreal Engine is better coded towards 3D, and a lot of cool 3D games, AAA titles like your favorite game Fortnite is created using Unreal Engine. Now the third game engine, and that's like the baby game engine that's upcoming and taking everything by storm, is Godot or Godot or however you want to pronounce it. I don't care. I don't want to see any hate comments below, okay? Anyways, Godot is a very good game engine. It started out as a small project between friends, I believe, and it started to go towards something bigger and bigger, and now it has a huge community. It uses GD script or Godot script, however you want to call it. And it also uses C# programming language for creating games inside of that engine. And GDScript is very similar to Python. So if some of you guys have coded in Python, it's a very similar language. Now, which games can you create using Godot engine? Well, you can create both 2D and 3D games. So basically, these are the three. And which ones I recommend to complete beginners for you to start with? Well, I recommend either Godot or Unity. But if you are serious and you want to jump into more complex development, you want to create, want to spend like 6 months, 1 year developing your games, you should jump into Unity because it's more flexible, it has more tools. Again, I'm not saying this engine is better than this one. I'm saying which one is easier for you to start and which has somewhat better tools that you can use to create your desired games. But if you just want to learn the basics of game development, starting out, how to create a game, what goes into creating a game, so on and so forth, you can use Godot as your starting point. Learn C# if you want to transfer to Unity. And if you don't, well, learn GDScript. So basically, these are the three engines that are going to crush it in 2020 and going forward from there.
So as you can see, Unreal Engine has very good graphics, whereas Unity is a lot more cross-platform friendly, if you like. So let's have a look at the popular gaming platforms. PC is extremely popular with the hardcore gamers and also the game developers. You can, download games off things like Steam. PlayStation, obviously one of the big consoles. Xbox, same. And Nintendo Switch. Then there is also mobile, which is for more sort of casual gaming. And then you've got VR headsets like the Oculus or the HTC Vive. And as mentioned, the distribution channels are Steam, the App Store, Google Play, PlayStation Store, Microsoft Store, itch.io for more sort of indie games. And then you've got your traditional brick and mortar stores such as Game, which are in most shopping centres. So this is an overview of some of the sort of more popular game genres. You'll be very familiar with some of these. RPGs, role-playing games, platformers, 2D, 3D, open world such as Grand Theft Auto or Red Dead Redemption 2. Sports games like FIFA, simulators, a very good Microsoft simulator, flight simulator around at the moment, and so on and so forth. So back to learning Unity. Last year the Unity Learn section came up with an excellent set of tutorials which is called Create with Code, which hopefully you've been shown at the very beginning of term, and it goes through step by step how to make a bunch of different games. And what we'll be tasking you to do in this unit is to create at least 3 of those games and show your work. So I would suggest when doing this is on your screen you have on the left hand side the tutorials themselves, and then kind of shrink down Unity onto the right hand side of the screen so you can see both of them at the same time. Another excellent introductory tutorial is Rollerball, which you can find on the Unity Learn section. And again, they provide you with all of the bits and bobs that you need in order to make the game, and it'll give you a good understanding of how coding works. Speaking of coding, a lot of you may be slightly daunted by coding. You may have had a bad experience when you're at school and they're trying to teach you Python or something. Whereas coding for games is slightly different. You are coding things like how the player moves, how to shoot projectiles, and other behaviours like the health and pickups inside the game itself. There's a lot of tutorials online about C# in particular, and so I'm not necessarily going to go through all of this code, but it's worth mentioning if statements. So halfway down this page you can see if and then some things in brackets. So an if statement is when you want the computer to make a decision based on certain conditions. So for example, if your player's health goes to 0, then they would die. So for those of you who don't have a particular mindset for actually coding with text, there is something else which has just been introduced into Unity called Bolt, and this is a visual scripting system. So what you can see there on the page is a bunch of what are called nodes, and you are hooking up the behaviors through the nodes instead of actually using code itself. This Bolt visual scripting actually does spit out code as well, so it's a good way to learn coding, especially if you're new to it. So let's take a look at a demonstration of someone who sets up a cube and makes it spin using visual scripting.
In this video, we're going to get started using Bolt, which is Unity's official visual scripting tool. It is very visual and very simple to use while also being immensely powerful. You can use it to make complete games or use it as a learning tool to help you learn programming. Let's begin! Hello and welcome, I'm your CodeMonkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Alright, so here we're going to learn how to do visual scripting in Unity using Bolt. Bolt is already a very robust visual scripting tool. It has been in development for several years now, and Unity bought them a while ago. Now, since Unity bought the tool, they have made it completely free for anyone to use. If you're coming across this video while being completely new to Unity, check the link in the description where I cover the Unity basics in a quick video. Here I will assume you know what are transforms, game objects, components, and so on. Okay, so Bolt is extremely easy to install and get started. First you go to the asset store and just search for Bolt and you'll find it. It's completely free, so just add to your assets and then click the button to open in Unity. When you do, it opens up the package manager. And down here you can see a button to download, so click on that and then click on import. So right away this only imports a few files, and as soon as it's done, go up here into tools and click on install Bolt. So it asks you a question and just click on import. And yep, now it imports all of the actual files. If you want, you can go ahead and just delete the install Bolt folder. Alright, so we see our very nice wizard tool. Let's go ahead, hit next. And now here it asks you a very interesting question. So do you want human naming or programmer naming? Now this is a really interesting question because it depends on what your goals are with visual scripting. One of them will show you nodes and actions pretty much just as standard English. So for example, it says list of game object. Whereas the other one will still work as visual scripting, but will show the nodes just like the underlying C# syntax. So it shows exactly as you would write code, so a list of type game object. So if you have no concept of programming syntax at all, it might seem like human naming is the way to go. However, I would strongly encourage you to go with programmer naming. Now the reason is because even if you have no interest in learning written C# programming, it is still a huge help to know the absolute basics. It will help you communicate with programmers and easily find solutions for any problem you have. And by just using programmer naming, you will be exposing yourself to basic programming syntax. So even if you're not intentionally trying to learn C#, you will learn it as you use visual scripting more and more. But at the same time, just like it says down here, you can change this at any time. So if you feel intimidated by programming syntax, you can start off with human naming and then later on transition into programmer naming. Okay, so in this case I will be choosing programmer naming. Then here we see some assembly options. This is for more advanced users in case you want to load external libraries. In our case, we want to keep it simple, so just leave it all at the default and click Next. Then we have a list of types. Again, it's for more advanced use cases where you want to add your own custom types as nodes. So for now, leave everything at default and just hit on Generate. Alright, so after a bit, everything is generated and we have Bolt fully installed and ready to be used. Awesome. Let's hit close and yep, let's start actually using it. Let's try making the most basic example possible in Unity, which is to make just a cube spin around. So first, let's create a cube. So again, just a basic 3D object. Alright, there's a basic cube in our scene. And now to make a visual script, we can go up here to click on Add Component. Then we go under Bolt, and in here we're going to add a flow machine. Okay, so right away we see some options. We see a field for a macro. The macro is really the script. So go ahead and click on New, and just save the macro anywhere. In this case, let's call it our spinning cube. Alright, there it is, and now we can also add a title and summary if you want, so let's just say. Alright, so there's our macro. Now let's click on Edit Graph. And yep, right away the graph window pops up. So we can already see the default state of our graph. We have a start event, which is fired just once at the beginning, and an update event, which is fired on every single frame. So this is the graph window where we're actually going to draw our graph. And there's another window related to Bolt that's also very useful. So go up here into Window, and we're going to open the Graph Inspector. This one works basically the same as the normal inspector, except it's for when you select nodes inside of the graph. So for example, selecting the update node, and over here I can see, yep, there you go, update is called on every frame. So let's dock it right next to the graph, just like that. Alright, so here's our basic layout. We have the graph and the graph inspector. Okay. Now let's remember what's our goal here. The goal is to spin our cube. So what that really means is to rotate it on every frame. So let's start off by getting rid of the start event since we don't need it. And now we can go up here to our update event and click and drag out this arrow. And as soon as we drop it, yep, there you go, it shows a menu with all of the actions that we can take from this input. So if you want, you can browse around this list to see all of the nodes that are available. So for example, over here you see a whole ton of math functions. Then here we can access some collections. And under Codebase we can access pretty much anything. So as you can see, there's tons of nodes to do exactly anything you want to do. Now, since there's so many of them, the better approach is simply to use the search bar. Now we want to rotate, so let's just type in rotate. And as soon as we do, we see a whole bunch of rotate methods. Now in this case, what we want to do is rotate our transform, so it's going to be one of these. And we can see that they take different types of parameters. Let's just select the simplest one, which is this one here, which just takes 3 floats. So click on it, and there you go, there's our transform rotate node. And here in the graph inspector, we can also visualize all of the inputs and outputs. So the first input is the flow, so it goes from event into there. Then we have the target, which is going to be this object. And then we have 3 floats. Then for the outputs, we just have an output flow. Alright, so in this case, let's just rotate it on the y-axis. So over here, let's just hit 1. And yep, that's it. This is all it takes. This will add 1 to the object y angle on every single update. So just like this, let's test. And yep, there you go, we have our very nice spinny cube. Awesome. Now, one really cool thing about Bolt is how you can visualize the flow inside a graph. So we can see that the update event is constantly being fired and is being received by the rotate node. So this becomes an extremely useful feature as your scripts become more and more complex. Okay, so this is the most basic graph. Now, when it comes to scripting, one very important element are variables. So let's look at that. So for the variables, there's another window we can open. So again, go into Window and open up Variables. Alright, so here we can see tons of variables that we can use in our scripts. Let's dock it right next to the flow graph, so right underneath the graph inspector. Yep, there you go. And now here, just a quick Unity tip. You can make the active window full screen by clicking on the window and then hitting on Shift and Space. And there you go, just like this, it makes the current window full screen. Alternatively, you can also click on this full screen button. So it goes from that to that. Or just double click on the window itself. And on these buttons here, you can switch these from the left side to the right side. Personally, I prefer on the right side. So here we have a bigger area to work with. Okay, so to make a variable, it's actually very simple. Down here on the graph variables, we can click on here in order to input a variable name. In this case, let's call it our speed variable and click on the plus icon. And over here, we need a type. Now for our speed, we want it to be a float. So yep, select float. And then some default value. So in this case, let's set it to something like 3. Alright, so that's it. That's our variable all set up. Now we just click in this position right here and then drag it into our graph. And there you go, here we have our getVariable node. So from this port out here, we get whatever value is stored in the variable. So we just take this one and connect it onto the Y angle. And yep, there you go, now it's going to rotate our cube based on the speed that we set in the variable. Alright, so let's test. And yep, there's the cube now spinning faster. And again, Bolt is awesome and shows us the flow of values that are going into the inputs and outputs. So we can see that over here we have a 3 being sent from this variable onto this input. And if we modify the variable in here, instead of 3, let's say 9, and yep, there you go, it automatically updates. So even while the game is running, you can easily modify the code. Right, awesome. Now let's try doing another basic thing. Let's listen to some input and make our cube jump. Now, in order to make it jump, let's add some physics. So for that, just over here on our normal cube game object, let's add a rigid body component. Yep, there you go, just like that. And let's also make a floor so it doesn't fall into infinity, so just create a new plane. Alright, so here we have our cube, it's rotating and falling along with gravity. Now here in our graph, let's expand it. And now let's right click and we're going to add something. Let's search for add force. And we're going to apply some force to our rigid body. So let's go with this one that takes 3 floats and then the mode. Okay, now here we want to jump up, so let's add some value on the Y. And for the mode, let's select impulse since it's meant to be instantly applied. Okay, so here's what we want to do, just add some force on the Y, alright. Now we want to trigger this on a key press. So let's right click and we're going to search for get key down. Yep, there you go, input get key down. So once again, you can look in the graph inspector to see what it actually does. So it returns true during the frame when the user starts pressing the key down. And in here for the key, let's select the space key. And now we have our 2 outputs. One of them is the simple flow and the other one is the boolean. So this boolean will be true when we press the spacebar. And we only want to run this rigid body when that one is true. So now the question is, how do we connect these 2 nodes since we can't directly link the boolean in there? And now what we do is let's drag the boolean and right away we see our little selector and let's select our branch. So this branch node takes an input, it takes a flow, and then we have the output, which are 2 flows, one of them if it's true and one if it's false. So if it's true, then we want to run and actually add force to our rigid body. And we also need to connect the flow to the branch input. Okay, so that's set up. However, you can see that these nodes are slightly transparent. That means they're not being used at all. Now, one key concept in programming and running code is the flow of execution. Essentially, the code runs line by line. So it runs the first line, then the next line, and so on. Here we can visualize that same process with the flow of execution. So we start off on the update, then we go and we execute the rotate node. And then after that, we need to connect this into the get key down, which will then run this one, then run this one, and run this one. Essentially, there always needs to be a continuous flow from start to finish. And right now you can see they're no longer transparent since they are indeed being used. Alright, so here's our complete script. The cube will always be rotating based on the speed set in the variable. And then if we press the spacebar, it will add force on the rigid body and make it jump up. Okay, so let's test. Here's our spinning cube, and down here on the graph we can see exactly what it's doing. So the flow is constantly running, but yep, there's no flow in here since it only runs when this one is true. So now if I press on the space key, yep, there you go, the cube jumps up, and you can see that one become activated for exactly 1 frame. So since I press, yep, there you go, you add some force, and he moves it upwards.
So a game design document is something that you would put together at the very beginning of development, or if you are pitching your game to be made. So in this case, because we're using Create with Code, you are going to have to sort of backtrack a little to come up with a story, unless you're making your own game from your own idea that you've had for a while. Anyway, the point of the GDD is to tell what is the story of the game, who are the characters, what's the environment of the game, how does the gameplay work, what is the art style, what are the sounds going to be like, and what are the UI and the controls. So like I've said, for this Create with Code project, you're going to have to sort of back engineer the story a little bit and make it fit with the games that you've been making with Create with Code. But everything else should be pretty self-explanatory there, and we would like you to put together a presentation in Google Slides, which has got these page titles. So audiences, people tend to think that the stereotypical gamer is an adolescent male, But this is changing over time, and games are becoming a lot more inclusive and a lot more diverse in their audiences. Things like, having very, very casual mobile games, or certain games such as Kingdom Hearts and SingStar have a different demographic apart from your usual adolescent male. So just something to think about there about audiences for games. People tend to just say that games are for everyone, but what you need to do is break down exactly who is it going to be for. Just a quick mention about the alternatives to Unity. Obviously there's Unreal Engine, but there is also a game for the PlayStation 4 which is called Dreams, and that is essentially a game engine in itself. So if you happen to have a PlayStation 4 and you've got 20 quid to spend on Dreams, then it's probably a good investment for this course. Also, there's this other thing I want to mention called Core Games, which is at www.coregames.com. And this is a games engine which is based on kind of Unreal Engine's graphic capability, if you like, and you can get some really stunning results. It's unfortunately only for PC, but hopefully you are all using a good gaming PC at college, and so I would suggest downloading this and going through some of the tutorials on there. So as ever, for all these units, you can find a lot of the information that you need in order to fill in the task sheet in your unit materials and resources document. And also there's links in there to things like how to make a simple movement script in C#, which you will be asked to do in your task sheet as well. And so, everything is there for you to be able to complete this unit. And thanks for listening.